Yes, welcome back again. This is the third problem on principle of superposition. Find the total elongation of the bar shown below. Take Young's modulus E equals 200 GPa. See here, if you observe this diagram, so first this part is square section. So this second part, it is uniformly tapering circular section, and at the end this part is again square section. So by observing the diagram we can identify the type of section. Clear? So let me list the data. So I'll call this as section 1. This is my section 2 and this is my section 3. See here, first L1, length of section 1, so 2000 millimeter. So here it is in meters, I have converted to millimeters. So L2, which is also same, 2000 millimeter. L3, so 1000 millimeter. Next, let me convert the Young's modulus. Young's modulus E is 200 GPa. So if you convert the Young's modulus, so it will be 200 into 10 raised to 3, 200 into 10 raised to 3 Newton per millimeter square. So let me calculate the area A1. So here the diameter is 50 millimeter. So pi into 50 square divided by 4. So which is equal to 1963.49 millimeter square. So here we don't need A2. So next I will straight away go to A3. So here it is diameter 20 millimeter. So pi into 20 square divided by 4. So A3 you will get 314.15 millimeter square. So in this problem it is required to calculate the elongation, which means delta L. So first let me consider section 1. So this is my section 1. Here you have 60 Newton. So let me find at this face. See here, you have minus 50 plus 90 minus 100. The forces which are moving towards right are taken as positive. The forces which are moving towards left are taken as negative. So you will get minus 60 Newton here. So minus sign represents the direction of the force should be towards left. So 60 Newton. Clear? So length of this section 2000 millimeter. So for this section delta L1 calculated by using the formula P1 L1 divided by A1 E. So let me substitute. P is 60 Newton and the length of the section 2000 divided by area. So already you know the area 1963.49 and your Young's modulus. So 200 into 10 raised to 3. So the Young's modulus is common for all the three sections. Let me use the calculator. So 60 into 2000 divided by 1963.49 into 200 10 raised to 3. Sorry. Sixty into 2000 divided by 1963.49 into 200 into 10 raised to 3. You should be very careful while calculating. So delta L you will get. So here it is delta L1. So you will get 3.055 into 10 raised to minus 4 millimeters. So this is delta L1, elongation for section 1. So if you observe this diagram, this section is subjected to compression force. This section is subjected to compression force. So let me find elongation for second section. Okay, this is for first section. So you note down the answers. Later it is required to calculate the final extension. So I will remove this. So let me calculate delta L2, which is elongation for second section. See here, it is uniformly tapering circular section. So length of section 2000 millimeter. At this end, you know the diameter 50 millimeter. Similarly, at this end, so diameter is 20 millimeter. Let me calculate the force at this section. So here it is 60 minus 50. You will get 10. You will get 10 in Newton. It is positive. So then you have to take the direction towards right. So it is 10 Newton. Next, let me find the force at this section. So 90 minus 100. So here it is minus 10 Newton. So this negative sign indicates that you should take the force towards left. So this is 10 Newton. As the section is uniformly circular section, so delta L2, which is calculated by the formula 4PL divided by pi E multiplied by 1 divided by D1 D2. Here we should not use the formula PL divided by AE because my section is uniformly tapering circular section. So let me substitute the values. So 4 into P 10 Newton, length 2000 divided by pi into Young's modulus 200 into 10 raised to 3. So 1 divided by D1. Here it is bigger diameter 50. D2 smaller diameter 20. So let me simplify this by using the calculator. So 4 into 10 into 2000 divided by pi into 200 into 10 raised to 3. So 1 divided by 50 into 20. So elongation delta L2. So it is 1.27 into 10 raised to minus 4 millimeter. So this is delta L2 elongation for second section. See here, if you observe this section 2, second section, again this section it is subjected to compression force. Compression force. So let me find, so next let me find delta L3. So for which I will consider section 3. So section 3, so it will be like this rectangular section. At this face you have 100 Newton. So let me find at this face. So it is 90 minus 50 plus 60. So it is 100 Newton. So positive. So we should consider force towards right side. So 100 Newton. Length of this section 1000 millimeter. So already calculated the area. So next it is very simple. Delta L3 equals P3 L3 divided by A3 E3. So P is 100 into length 1000 divided by A3. So 314.15 multiplied by Young's modulus 200 into 10 raised to 3. So let me simplify this. So 100 into 1000 divided by 314.15 into 200 into 10 raised to 3. So you will get delta L3 as 1.59 into 10 raised to minus 3 millimeters. So once you get delta L1, delta L2 and delta L3, so next your job is to calculate the final elongation or total elongation. See here, this section 3 is also subjected to compression force. Clear? So let me find the total elongation. So total elongation delta L equals delta L1 plus delta L2 plus delta L3. So here in this problem, all the three sections are subjected to compression force. Whenever there is a compression force, there will be a decrease in length. So I should use negative sign. So first minus 3.05 into 10 raised to minus 4. So next minus 1.59 into 10 raised to minus 3. Next minus, sorry, so here it is minus 1.27 into 10 raised to minus 4. Next minus 1.59 into 10 raised to minus 3. So let me find the total elongation. So first it is minus 3.05 into 10 raised to minus 4. Next minus 1.27 into 10 raised to minus 4. Next minus 1.59 into 10 raised to minus 3. So this is your final answer. So final answer is minus 2.022 into 10 raised to minus 3 millimeter, or it can also written as, so delta L equals minus 0.00202 millimeters. Both are same. See here this negative sign indicates, so there is a decrease in length. If this is your final answer is positive, then there is a increase in length.